All right, welcome back, everyone. Next up, we have Manuel and Nathan, two experts on building airtight enterprise frameworks. Welcome.
Thank you. Good morning, everybody. Thank you for coming to our talk. Welcome to YUI 2013. Today, Nathan and I want to show you how we took YUI and we wrapped them with closure templates, and we created a powerful set of enterprise JSP tag library. So a little bit about ourselves. My name is Manuel Jasso, and I'm a front-end architect working for Wells Fargo Bank. And we've been trying for many years to do UI right or better in Wells Fargo. And with me is Nathan Comstock.
My name is Nathan Comstock. I'm a web developer at Wells Fargo also.
And so just to give you a little bit of context of our company, I think most of you know Wells Fargo. I'm probably customers there. I'm a customer there. There's three major areas. Is a personal finance for individuals like you and I. That's the part that I think most of you know, wellsfargo.com. Then we have small businesses for companies that are up to $20 million in annual revenue. And then we have the big boys, the commercial, which is for businesses well over $20 million in revenue. And that's where Nathan and I do our work. So our clients are these mega companies with trillions of dollars of transactions, and we have to be, we have to do things right there. So we have a few constraints that we have to deal with on a day-to-day basis, and the number one is security. Nothing gets done in Wells Fargo without a lot of thought of security review. Our transactions and the data of the customer has to be well taken care of. Also, of course, performance. That's familiar for everybody here. However, in our case, we have to continue to learn how to do performance on the client side better in mobile, like most of us are here in this talk. Also, we have to deal with ADA compliance. The government mandates that financial institutions such as ourselves, our applications have to be usable by people with disabilities, people that cannot use a mouse, for example, or people that have vision problems, low vision, or even blind people. And they have to be keyboard operable, and they have to work well with screen readers, which is super, super challenging for if anyone has done that. It's really difficult to do. We have typical challenges, I think, for front-end today. We have to support multiple browsers, tablet, mobile touch, although I have to say that this is also fairly new for a company like a financial institution. Up until a few years ago, we had to worry mostly about i6 and 7, and we didn't worry about nothing much. Because we have to do all this support now, our executive said, hey, how about if we can do this and also do a little bit of rebranding and UI redesign. So our CSS architecture has to be done well in such a way that we can easily swap and change our branding, which is something that has been very, very difficult for us to do in the past. So we have to support different skins for like tablets and desktop, for example. Another interesting challenge for the commercial side where we work is that we have about 80 different applications. So we're not like one app or two apps. This is really 80 different teams, all of them, 20 engineers and a lot of people, and each one is like almost like a silo, and they have to do their own thing. So our job is to make sure that we provide to 80 teams consistency of the UI, scalability, and all these things that we've been discussing, and that's really, really tricky to do in an enterprise. So bottom line, we have to deal with lots and lots of Java and JSP legacy code. So what we have seen over these years is that when you have unconstrained design, when you can go into a JSP and you have very easy access to your HTML, you can write HTML in the JSP, you can write Java, you shouldn't, I think everyone knows that, but everyone does. JavaScript as well, you can throw whatever you want there, and CSS. So, JSP is kind of it's almost like an enemy right now at this point. And what I want us to invite people here to pay attention to is that we have a potential problem also within JavaScript, and that's the fact that within JavaScript you can easily access the DOM when you're in the browser, and you can also easily access the browser object model when you're in the browser. So it's super easy to write JavaScript and then you say document.something or window.something and you don't even think much about it, but boom, you are marrying two pieces that maybe you shouldn't be marrying at that particular point in time. So we have to be very careful with the constraint design because it leads to unmaintainable spaghetti code very quickly, very easily, which we all know prevents separation of concerns, and it prevents stripe principles. And although we have had patterns for many, many years to take care of this, I think we have new challenges, which is great, right? I think today we are dealing with really a distributed MVC that looks like that to us, and I think be familiar to most of you. We still have an MVC on the server. We still have an MVC on the client. They talk to each other. We know that on the server is really for forming the page, and on the client, that's when the page is formed. That's when you do what we know well what what to do. But today we want to focus and narrow down to the view. The view on the server is really an inert view. I think someone else also gave a similar talk, and it's, on the server you don't have DOM, and you don't want to have DOM, even if you can help some. And the other thing is, by the way, we cannot use a node. So all of this we have to do with, of course, Java JSP, which is the point. And on the client side, then, of course, you have an interactive view. So how do you marry these two things together? Well, very easily to think that you want to share templates across the board. So that was the bottom line of what we wanted to present to you, that how we share these templates between the client and the server and use the same thing, truly to share those templates. So with that, I wanted to show you a demo of a widget, which is going to be the point of the talk.
Not shared.
Oh, it's not shared? Oops. Boy. Sorry, we have to maybe move it. Okay, sorry, we'll have to do it like that. So this widget that I'm going to show you, and I'm sorry, this is going slower on purpose because that's another thing we wanted to show you. We're throttling these to be 3G, on purpose. But forget about that. This is the widget that we wanted to show you. We call it the section widget. It's super simple. It doesn't do much, but it demonstrates a lot of our principles. It has collapse expand capabilities. It has keyboard operations, so I'm doing this with my mouse. And under the hood, it has ADA compliance and all these things. So this simple widget, it's what we wanted to walk you through what we're doing to make it a reality. So with that, I'm going to let Nathan tell you about the details behind this.
So with our JSP tag library, there was two major things we wanted to do. One of the first thing was just to standardize how the markup's written from the server. So as Manuel was saying, you can mix HTML, CSS, JavaScript, Java all in the same code within JSP. So we really wanted to make sure that wasn't done. We also wanted to make sure that just the overall markup that's getting sent from the server is the same for each application rather than relying on individual server-side stacks to generate their own markup. But the primary thing that we want to do is render UE3-based widgets on the server. So this is kind of the foundation for most of our JSP pages. At the top, you can see what we call the page tag. So the page tag does a lot of control over the overall HTML that's sent back from the server. Here you can see there's a couple global YUI config attributes, filter and combine. So those, a developer can specify those in their page tag. The next tag is a script tag. So the script tag actually does just what you'd expect. It throws out a HTML script tag. But instead of just throwing it out wherever the JSP developer puts it, it'll put it in the request, store that. And then once we get to the bottom of the page, it'll render it out right at the bottom of the page, right where we want it. Same thing with the style sheet, but it'll actually do the reverse, so it'll put it in the head. The next comment with the JSP compilation error, that's just indicating that all of our JSP tags are what they call scriptless. So any attempt to throw scriptlets within your JSP tag is just going to throw a compilation error. It won't even compile the JSP. The next thing with the onClick, so just within our JSPs, it gives us like a little layer of abstraction over HTML so we can enforce certain things like you're not defining event handlers within your HTML, so we just don't allow it. That's something we inherited from a previous tag library version we had. And the final thing there is the YUI not defined. So this is just something that, since our page tag controls the location of the seed file that gets spit out, any attempt to try to use YUI within your JSP directly within the inline script is going to fail. Since we're controlling the seed file is always going to be at the bottom. So with this kind of code, you can't lint it, minify it. It's not cacheable. So it allows us to make sure that people aren't doing inline code like that.
So here we wanted to show you then the output of that JSP once it's compiled. So this is the plain and simple HTML. But it's important that all of our pages, again, think 80 applications, like 100 pages each application, we want consistency. The doc type is the right one, the language definition, the character set, i.e. compatibility mode, device scaling, all these things. Notice then that, for example, the link style for the familiar combo loader, which we have our own combo loader internally, it spits out the base CSS that we want to have on every page. And then you'll notice my CSS.css, which is the JSP application the developer wanted to have for his own CSS on this page. So we make sure it's thrown at the top of the page. And then we make sure also to stamp the body class with a familiar skin. that we all know here. And this is what the bottom of the page, of every page, looks like consistently. So we have the YUI seed file, which is spit out by our page tag. And the developer wanted to use the raw version, so that's what he gets. We also load some base CSS and other base components, right there. And then we start rendering out in the page the other JavaScript tags that the developer wanted, like my.js.js, which you saw in the JSP code from before. So with this, I'm going to let Nathan show you a demo for that.
So the
Oh,
not yet.
yeah.
So the primary focus of our JSP tag library was to render widget server side. And as Manuel mentioned earlier, one of the first things we needed to figure out is what template library to use. So there was three that really kind of fit our bill as far as being Java and JavaScript, so having Java and JavaScript support. We ended up with choosing Clojure templates, obviously. A couple of the things that were really good about that were the deciding factor was that it was a single project, so we weren't relying on a JavaScript version from one project and a Java version from another. It obviously had a lot of production cycles with Google, and it just was well supported. It had all the features that we really wanted. Some of the key features are contextual auto-escaping. So this first line here is just what the template is, and you've got three variables. They're all actually the same variable, but they're just used in different contexts. So the first one you see is an HTML attribute. The second one is a URI that's an HTML attribute, and the last one is just HTML. So based on the template from the first line there, the Clojure template compiler will just compile all these out and apply the appropriate routines for each variable based on the context and how it's used. Namespacing. So the Clojure has this concept of namespace where each soy file defines its own namespace. That works really well with YUI type modules because you can have a single soy file, multiple templates, and they all compile out to one, what we call a template module. Pre-compiling is absolutely required in Clojure. They don't have any JavaScript compiler, which works out well for us because for performance reasons, we always want to pre-compile. So that's something we liked. Line joining, so you can lay out your templates any way you want. You can format them nice, indentation, all that kind of stuff. And in the end, the compiled function is not going to have any of those extra characters, no new line feeds, so very tight output. There's a lot of other features in there, delegates, I18N, that kind of stuff that we just don't have time to cover today. So here's a very high level of how soy fits between the Java and the JavaScript in our library. So everything in the gray that you see there is JavaScript module. Everything in white below is our Java source. So we have a single soy file. That soy file lives within a YUI style module. That template gets compiled, and it's just any other YUI style module. So you can use that and require it in any one of your JavaScript modules. So that works out really well for us. At the bottom, you can see how it's used in Java. So each widget that we have, there's a Java model for that. So here you're looking at section.java. That's really our model that contains all the attributes that are used on the server side to actually render that are passed to the template when we want to render on the server. So there's an annotation on each one of our models. At build time, we go through, process that annotation, and generate a little class that will define how that model is rendered. And then there's a very thin wrapper just to meet the JSP tag API requirements. So this is what it looks like in source. The only thing you see different here from any other YUI style module is that there's a templates directory with our soy file. And when we run that through the Clojure templates compiler, we just tell it to dump it out in the JS folder. And then from there, Shifter builds it.
And this is an example of the actual soy template for the component that we're showing you, which is the section. So you'll see there the namespace declaration, the auto-escaping declaration to turn it on. Again, you can have a lot of templates within one soy file. We're just throwing two there for you to see how it looks like. For example, the body is just this div class. It's using, section is a standard mod component, so you'll see the body, header, etc. That's the widget body declaration there with our, body for skinning. Role region, again, if you remember, that ADA is one of our primary concerns, so we have to make sure that everything we emit from HTML, etc., is ADA compliant. So that's an ARIA role that we have to make sure it's there. And then, of course, the body content that the developer may have thrown at it. Section is an open container, so anything can go inside there. And then the header template goes there with whatever. So again, just to give you a hint of how that looks like, and this is what it gets compiled. So you'll see the familiar wrapper with YUI add and YT section declaration, etc. It became with shifter, etc. It became a regular YUI module that we just load with requires. And then you'll see there then the body function that was generated by the compiler, and the div class that we saw from before, and that was the auto escaping in action, and same thing with the function, etc. So that's a result of the compilation.
And this is just a simple example of how we use it. So we have a section widget that uses widget standard mod. So we just override one of the methods there and just call our own template. So we're calling YT section, standard mod section, passing in our data, and the resulting HTML just gets passed to node.create. So to give a little context to why we're doing this, there's 3 basic rendering patterns that we're looking at. One is just pure JavaScript rendering, the other one's progressive enhancement, and finally the one we focused on was the server-side rendering. So with JavaScript, you guys probably all know this kind of stuff, but it's all just, there's no pre-existing widget-specific HTML on the document, and there's no widget-specific CSS. You only get it when you use it, when you use the module. So here's a simple code example of how we would do that with section. You just put a container where you want to render to, create a new instance, call render specifying where to put it. And that looks, let's see, like this. And again, we got Charles throttling, so it's a little bit slow just to demonstrate.
Because we want to show in the end the effect of, this is what a 3G network looks like, and so, it's very dramatic to see how long this takes really to show on the page. So the second pattern that I think also many peers familiar is a progressively enhanced pattern. So the characteristics typically are there's some partial pre-existing markup on the page. There's some HTML there, but still we have seen that normally the CSS is still loaded when you actually use the component. So you have to deal with flashable style content, for which we have a solution suggested from YUI, which is to use the widget loading class to hide it maybe you want. And you definitely have to use the HTML parser because you want to find the pieces in the DOM. And so this is an example that is very typical, familiar. That's a section container. There's a familiar UI3 widget header, body, etc. And our header, in our case, if you remember, it's a collapse control. So we have the header counter and the toggle content. And that's the JavaScript version. Again, it's very well known. But of course, it's easy to see that it gets reduced because the only thing you need to pass to it is just the source node. And so we all know how that looks more or less. But we wanted to show the impact of that you see instantly the HTML because everything, as you can see behind the scenes, this is a 3G network, so we're loading. And then eventually the CSS comes, and then eventually JavaScript comes, and then eventually you have a functional widget, right? So that's the progressively enhanced pattern that we see most of the time.
So as I said, our focus is on server-side rendering. So in server-side rendering, you send the full widget HTML. You send the full CSS for the widget within the document from the server. And then the benefits here are obviously there's no flash unstyled content, and you don't have to hide any of your widgets while your JavaScript's loading. And same as progressive enhancement, you need to use HTML parser to pull out all the attributes for your widget. So it looks very similar. So this is using, our solution is obviously JSP tag based. Here you got the script to pull in to actually instantiate and render it with JavaScript. But the major thing we're looking at here is the section tag where you're passing in all the attributes to your widget. And then you may have nested tags that contribute to the overall model of the section. So here, section header, section toggle, you may need to have subtags that just contribute to the overall model. But in the end, you're rendering the full markup in CSS. So the JavaScript is exactly the same as the progressive enhancement. You're just specifying the source node and calling render. And what it looks like
So again, we wanted to show you that with 3G and all that, you instantly saw the component fully formed, fully there. And we still have JavaScript loading, etc. for a while. And the component eventually becomes fully responsive. But at least by perceived performance, it's much better because everything is well formed and well structured on the page right away.
So to get this working for us on the server, there's a few key things we needed to do. CSS was a big one. So just because you use, for example, if you use a single button on a JSP page, you don't want to load your entire library CSS. So we needed a way to be able to say this JSP tag requires this JavaScript module or CSS module. Second, you have to be able to resolve actual URLs to your combo CSS for that module. And this is in the Java environment, so you don't have loader to do that for you. Second, the HTML, our solution there was Closure templates so that we could share templates on the client and the server. And just like progressive enhancement, you have to use HTML parser to make sure you can pull out all the attributes from the DOM for your widget. So to declare a dependency, a module dependency for a JSP tag is just a quick sample of the code. So again, this is our Java model of the section widget. And here we just say requires equal whatever array of modules that component requires, and at build time, that's included as part of this class. So to resolve actual URLs for our CSS out of those dependencies, so just because we require YX section, we need to be able to actually get those URLs. So at build time, we use Phantom.js and y.loader to build up a big configuration file that contains all of those. So when a JSP tag is processed, it'll consult this file, it'll pull out all the CSS that it needs.
Okay, so with this, we wanted to show you the result of putting not only the section component, but other components on the page. Again, remember, we're throwing through Mimic 3G, but wanted to show you that even if you have multiple components on the page, everything it's rendered almost in one shot. Behind the scenes, we still have all the JavaScript. So there it is. There's many components that you can see there, and I know you can see there down there. There's still a lot of stuff going on behind the scenes with the 3G network loading. But here it is. This is a page that has many components. Some of them are, of course, very familiar from YUI. This is, of course, a typical button, but it's, of course, skinned to our needs, and it has a lot of ARIA and accessibility extensions. This is the section component that we're focusing on today. Up here, we have the very familiar tab view component with all of our extensions and skins and accessibility features, so on and so forth. This is a tree view. This is a tree view component that we inherited from SmugMug, by the way. Thank you to those guys. And then, again, the accessibility features, etc. So we are putting a lot of effort into making sure that the first page load, it's as fast as it can possibly be. And of course, after the fact, we're all familiar that JavaScript kicks in, and it's the same JavaScript code that we've done for a while. So this is a sample of what we have been doing, and we have a lot of components that are giving us this kind of result. So during that journey, we have learned a few things that we wanted to share with you. Number one is designing with constraints is very good. It prevents technical debt. So when you have a problem, you say, oh, I wish I could access something here. Maybe that's a good thing. You don't want to have easy access to things because later maybe you realize it wasn't a good thing to put together. Don't confuse HTML with DOM. That sounds kind of silly to mention for people here, but we have found that sometimes it's easy to confuse them. HTML is just text, like JSON, and DOM is memory. And you don't want to do DOM on the server, right? You want to do HTML on the server. Avoid unintended coupling between JavaScript and DOM. Same message. Separate your concerns. Separate your templates from your rendering and your DOM and events, etc. Plan carefully where to allow extensions and overrides, and include your template. We have found that not all YUI components allow us to have an easy way to extend them, because sometimes the templates were hidden or private or in static places, things like that. For server-side rendering, strive to emit fully formed HTML from your templates, and don't do like little bits and pieces like div, because if you emit that kind of template, you need DOM to keep filling in the blanks, and that's the kind of thing that gets in the way. Another way to say the same thing is you want to avoid using y.node or y.event during the rendering cycle. Later, of course, is fine. After it's been rendered, you do whatever you need to do. Other lesson learned is separate the server view from the client view. This is something we showed earlier in our distributed MVC model, so that you don't mix that code and make it easily to separate. Another takeaway is try to make your code, think about making your code extensible and testable. So use prototype-based protected methods and properties. This is always a struggle. You want to have privates that are really privates in a closure and all that, but that makes it hard to test and it makes it super hard to extend. We have found that as long as you clearly document that your code is protected, which is meant to be extended by subclasses, should be perfectly fine, and it's easy to extend then in that situation. Don't use static properties to store template definitions, or actually any other thing that you may want to allow extensions to. It makes it awkward, because if you're changing that static, then you're changing the template for all the class tree, and you may not want to do that. And last but not least, this is a good old thing from many, many years before. Use the factory pattern. Watch out for, sometimes you have components that are composites and they instantiate other components under the hood, and we see sometimes that the component says, okay, new foo, without allowing a potential subclass to create an extension of foo for them to do it. So the factory pattern is very good for that. So think about that. Think about when you want to permit other people to extend your components to make it easy. So with that, we wanted to thank you and see if you have any questions, and that's our contact information. Thank you.
Thank you, guys. We have time for one question, so if you have one, please raise your hand. Great job. Thank you.
Thank you, Jenny. Thanks.